Okay, well, it's 3 minutes past three. So thank you very much, everybody, for coming to this Energy Research Accelerator webinar today for Net Zero Week. My name is Nick King. I work for the Energy Research Accelerator, and today we're going to be talking about research for net zero, driving innovation and impact. It's a flavour of some of the research work that we do, and we'll be talking about how you can potentially become involved. So firstly, just want to thank Net Zero Week for giving us this opportunity today. We're one of the supporters of Net Zero Week and have been for a couple of years now. So the week involves a whole range of different events and webinars. Yesterday I was in Portcullis House, Westminster, taking part in a debate that we were doing on battery technologies. But there are all kinds of webinars taking place over the next couple of days. So please have a look at the Net Zero Week website when you have a moment. So just in terms of today's agenda, I'm going to be talking, giving a bit of background to the Energy Research Accelerator. Then my colleague Sarah Gomez from Loughborough University will be talking about a new tool that we've created called PACER to help measure carbon emissions. And then Neil Radford, our skills director, we'll be looking at skills for net zero, and we have a number of doctoral students who will be presented today, Monica, Mandy and Steffi, and then we'll finish the session with some Q&As at quarter to four. And please put your Q&As in the chat as we go along, and we'll come to them at that point. So if you didn't already hear me, please can you mute your microphones so that you don't disturb the presenters as we go along. So the Energy Research Accelerator, just a little bit of background to who we are. We started 10 years ago. We had funding of £60 million from government at that time, which we've invested in new equipment, new facilities and demonstration projects across our partner universities, who are all the universities at the bottom, along with the British Geological Survey. So we connect together 1,400 researchers. We've got, as I say, we had £60 million that leveraged additional funding to raise it to 110 million, and that money in itself has kind of leveraged a further 250 million, we estimate, in terms of other programs and research projects that we've done. Just to give you a flavour of some of the facilities we've created. So at the top here, we've got the Trent Basin. In Nottingham, Trent Basin is a community energy scheme. It had at the time what was the largest community energy battery in Europe. People involved in the scheme were all part of the energy company. They were able to resell their excess energy back to the grid through the energy company. That reduced their bills. And we put in all the sort of solar power panels and the battery and technologies for that. Just below that, we've got the RAD building in Nottingham, which is one of our flagship facilities where we do things like we have hydrogen labs, thermal energy, carbon capture and storage, all taking place in that building. Below that, the Geoenergy Testbed, which this is a British Geological Survey project. This was a project where we funded them to undertake some boreholes that they dug at the Sutton to Bonington University of Nottingham site in Leicestershire to see how the CO2 permeated through the geology, which is very similar to the geology of the North Sea. And we sort of provided them with test equipment like drones and other facilities and equipment that they could use to test what was happening to the CO2. The bottom there is part of the Energy Innovation Centre in Coventry. That's an inductive charging facility, but we funded their battery innovation facilities where they test batteries to destruction, where they manufacture to a certain scale to prove concept, etc. Then on the left-hand side, bottom left, is the Energy and Bioproducts Research Institute at Aston University, which is Europe's leading bioenergy facility that we've supported. And then at the top there, for those of you who might be in the West Midlands, that's the Tyseley Energy Park, known as one of the most innovative energy parks in the UK. And there we funded energy from waste facilities and have supported a number of other projects over the years, such as hydrogen and ammonia, etc. Um, so in terms of other things that we do, what we do is we bring people together to focus on challenges. So one of the things that we have set up over the last couple of years is something called Midlands Nuclear. So we worked together with the Midlands Engine at the time to bring together companies, universities, and others that were involved in the nuclear sector or who wanted to get involved in the nuclear sector, because we want to develop that supply chain. So if you don't already know, if you're not from the region, so North Nottinghamshire has been chosen as the site for the new step fusion generator, which is the picture on the right-hand side, and that provides a tremendous opportunity in terms of supply chain of skills, etc. So we've looked at skills that we need, and we've looked at other opportunities for siting nuclear technologies in the Midlands. Midlands also home to Rolls-Royce, of course, who develop SMRs, small modular reactors. In terms of an example of a project that we've done, so we're technology agnostic, but this particular project was on hydrogen called HyDEX. So this was a project where we helped to stimulate the economy in the Midlands, bringing together people involved in the sector, looking at what was needed, looking at the skills needed, developing things like hydrogen schools. We put together demonstrator projects at different universities, looking at new ways of storing and producing hydrogen. We looked at things like policy. So that's one of the documents we presented there, looking at the potential for hydrogen use in rail. And then we supported business as well with innovation grants. And you can see in the pictures on the right-hand side, some of the sort of international work that we've done as well to sort of build bridges and connect with international colleagues. Just very quickly, these are some of the hydrogen innovation projects. The Hydroflex train in Birmingham, up to the left-hand side, Birmingham University were involved in that development. The Hyper test rig at Cranfield University. And to the right-hand side there, we've got the Cranfield Aerospace Solutions. They're involved in things like hydrogen aviation. And then at the bottom, we've got High Deploy, which was a project at Keele University, one of our partners. And they put blended 10% hydrogen into their gas grid at the university to prove the concept of blending hydrogen into the network. And then this facility is the hydrogen refueling station at Tyseley Energy Park, I believe. That's something that we've been involved with. And at the right-hand side there, the battery electrolyzers that they produce at Loughborough University. So it just gives you a flavour of some of the work that we've done and the projects we've supported. We also do work in policy, and this is something we'd be interested in talking to you about. If there are various policies that you think we ought to be looking at and supporting you with. So on the left-hand side, so when Labour were in opposition, as you know, they were talking about setting up GB Energy. So we did a policy commission looking at the potential for that and what pros and cons were for it, bringing together a panel of experts from across the energy industry and academia, etc. And some of the things that we recommended in there did actually find their way into GB Energy at the end of the day. So we can, potentially we may have influenced those decisions. Then other things I mentioned that we were involved in roundtables in Parliament over the last few months. If you could mute your microphone, please. Over the last few months, we've been involved in energy storage, roundtable, nuclear, energy for defence, and also battery technologies. And then we've looked at other things like energy from waste and thinking about how that fits into the circular economy. So just coming towards the end of the presentation, just to sort of give you a flavour of some of the things that we do in terms of research. We've got a number of special interest groups as well. We have a research committee and academics will sort of discuss with industry and see what topics are particularly of interest at the moment. So we've got a special interest group that looks at hydrogen. We've got another one that looks at nuclear. We've got one that looks at energy for defence. We've got one that looks at energy policy. But these are expanding all the time. We're likely to be moving into other areas as well. And if there are things that you think we should be doing, please let us know. And then just finally, if you want to get involved, we're always keen to hear from people. We want to connect businesses, help them do the research that they need, help them to innovate. There are projects that we're involved with now, such as Forging Ahead, which is helping to find funding for businesses, for businesses coming out of university and other businesses as well. We are developing skills. We're accessing facilities. You can access facilities at our universities as well. I've given you a flavour. There's more information on our website, and I can certainly send you a whole list of all the facilities that we offer. And funding as well. As I say, that's something that we're happy to help with. We're often working with businesses to put together bids for various initiatives. As I mentioned, the HYDEX project a little bit earlier. So that's all I want to say for now on the Energy Research Accelerator before I move over to Sarah Gomez. We've got our QR codes there if you want to link in with us or have a look at our website. So thank you very much for that. We're going to come to questions at the end. So if you've got any questions, please put them in the chat. We'll have a look at them when we get to the end of the presentations. So Sarah, over to you.
Thanks, Nick. So could we have the next slide, please? So hello, everyone. My name is Sarah Gomez. So I work in the Research Academy at Loughborough University. And today I'm just going to talk through about the PACER toolkit. So PACER is a new way to assess the potential avoidance of carbon emissions through research. And my role on the project has been around developing the online toolkit. So this toolkit was developed and designed to help researchers utilize the framework that CDICE have developed. So next slide, please. So what is PACER? PACER is a structured framework to assess how research outputs could reduce greenhouse gas emissions. And the framework can be applied to different types of research. So it looks at the potential carbon emissions avoidance if research outputs are implemented. So if you have a research project and the outputs are implemented and the societal benefits is trying to estimate those avoided carbon emissions. And so this helps researchers to consider carbon impact early on in their research areas, and that helps to strengthen their project relevance and also to strengthen their project reach. So that's just a very quick overview. Next slide. So why did we develop the PACER framework? So currently we've got carbon accounting mechanisms which focuses on scopes 1, 2 and 3 emissions. So these are all of the emissions associated with an organisation's activities. And this helps. So with this accounting mechanism, where organisations are able to understand and quantify their carbon impact and then look at strategies of how to reduce their emissions. However, these approaches don't necessarily capture the broader and longer term benefits of research. So the avoided emissions associated with research, and specifically how a new research innovation could potentially scale, adapt, and contribute meaningfully to those longer term climate ambitions. There are also some limitations in terms of the terminology around avoided emissions, and there are some frameworks that exist for avoided emissions, but there is a lack of consistency in assessing carbon avoidance. So this is where the CDICE team have looked at this gap in the market essentially to try and develop this framework which will look specifically at the avoidance of emissions within research. Next slide, please. So why PACER? PACER provides a common framework that researchers and funders can use to assess the potential carbon emissions of research projects and proposals. So it's designed to be flexible and it can be used across different disciplines. So you can see on the slide the different disciplines and also at different stages of a project or research development. So from early research concepts right through to mature technology. So when outputs of a research are ready to be implemented. And also the framework is suitable for projects with different types of impact. So if a project, for instance, is based on a technological innovation, or perhaps it's more around policy development or policy change and behavioural change, the framework is still applicable. So as a researcher, you will be able to apply this framework at any point of the project lifecycle, although applying it earlier on has greater opportunity to inform the project development and maximize the impact. And as a researcher, you'll be able to look at this framework and then go through it using your own project data. So if you've got specific project data, you can systematically work through the framework, and that will give you a deeper understanding of the potential avoided emissions that are linked to your research area. So I'm not going to go into too much detail about the actual framework. We've got a little partial image of the framework, but essentially it's designed as a series of questions to capture information required for the assessment, and there are different assessment levels. So depending on the type of project and whether it's the likelihood of its adoption within after like commercialization, there will be different levels of assessment. So you will either have a narrative assessment, a semi-quantitative assessment, or a quantitative assessment. And the framework will gather information across 4 distinct areas, which includes the impact sector and boundary, so which sectors will be using the research, potential markets and uptake, the implementation risks, and the other dependencies. So the toolkit kind of provides all of this additional information of how the framework can be applied to a real project. So that's where all the information is. So that for now, we're not going to go into too much detail, but we'll move on to the next slide, please. So in terms of the benefits for research, with the framework, we have better evidence for decision making because it reduces the assumptions that we're making in terms of what are our avoided emissions with this piece of research or this project. And because we've got that structured approach, we're able to then estimate the potential avoided emissions associated with the research. So it's just giving that the framework provides that structure. So this will provide stronger research design. It gives researchers more confidence in the potential emission savings that are attributed to their work, and that will then help them to avoid overestimating or overclaiming in terms of what benefits in terms of climate change their research applies. So this can help with funding applications, but also in terms of developing industry partnerships, it also helps with securing investment for any research outputs. And the PACER framework is underpinned by a peer-reviewed journal article published in Carbon Management. So as part of that paper development and also the framework development, CDICE has tested the framework against some of the projects that it funded. So that ensures that we've got a practical, reliable and robust framework for researchers to use going forward. Next slide. Benefits to researchers. So the framework is free to use for anyone. You can download the framework from the CDICE website. There are some guidance notes and also information about citation to the paper. And we've got this online toolkit. So this is the piece of work that I have developed or helped support develop. The toolkit essentially will work through some of the basic concepts in terms of what is carbon accounting, carbon emission factors, and then it will progress into the avoided emissions terminology and then look at a real project example. So it will guide you through how to apply the framework to a case study project. And this is one of the projects from the CDICE that CDICE has funded. So it's self-directed, it's self-paced. You can access the toolkit at your own pace. You don't have to complete it in one sitting. We've got some interactive elements within the toolkit. So we've got videos and quizzes and other digital resources. And so to get the best out of the framework, we would really recommend doing the online toolkit. And as part of completing the toolkit, you will also have an opportunity to earn the micro-credential. So this is one of the micro-credential badges that CDICE has developed for this particular framework and also the toolkit. And next slide, please. So just to finish off, here are some of our acknowledgements. So some of our funders and partners who have helped support the development of the framework and also the online toolkit. And we've also got the authors of the journal paper. But just in terms of a call to action, we would really like you can scan the QR code, that will take you to the CDICE website where you will be able to download or link to the journal paper. So please have a look at that journal paper. which talks about the whole process involved in developing the framework. But there's also the framework itself, which you can download from CDICE website. We've got the online toolkit. So this is hosted by University of Birmingham. So there's a link to access or request a login to be able to access the toolkit. And then if you've got any feedback, we'd really appreciate any feedback in terms of either the toolkit or how you have used the framework and how it's worked in your own research area. So that's it from me. So thank you for listening. I'm happy to take any questions at the end.
Thanks, Sarah. Thanks for that. A really exciting new development there at Loughborough. So now I'd just like to hand over to Dr. Neil Radford, who's going to talk about skills for net zero. Neil.
Thank you, Nick. As part of this webinar, so we've been showcasing a lot of the different types of activities that ERA do, and another strand to that is the ERA Skills Programme. My name's Neil Radford, I'm the ERA Skills Manager. Thank you. Next slide, please. So very briefly, I'm going to just do a bit of an outline of what we're trying to do with the ERA Skills Programme. And there is a link there to the website for it. We're focused primarily on doctoral and postdoctoral researchers and really trying to build that diverse pipeline of talent coming into the energy sector and driving innovation within it. So we aim to support a just transition to net zero by developing that high-level energy sector skill set across those groups. We work really closely with our 8 higher education providers, so our universities partners, so that we augment their training rather than duplicating it or overlapping with it. So we work with the CDTs and with the doctoral colleges in those institutions. What we try and do with our programme and the sort of key features of it is that we promote future research leaders, promote them through interdisciplinary training. So we really try and focus our events on interdisciplinary training, on getting industrial engagement with that training, so we're bringing industry into it, and through collaboration, so we're bringing those people together and getting them to work together and to forge new contacts, because it's through that kind of work that we're going to help to drive the agenda forward for the energy sector. So we aim to provide technical skills development. That's primarily through our university partners, and by exposure to technical skills, environments, and the infrastructure that Nick was talking about earlier, and so on. But we also look at the professional and transferable skill development. So we're really looking to encourage networks and encourage leadership skills within those groups. So on the next slide, I'm going to talk through, rather than talking through the whole programme, I'm just going to give you a couple of bits of flavour, if you like, and talk about a couple of examples that we've done. So the first of these is the community fund events, which we co-badged with CDICE, which you've just been hearing about, CDICE from Sarah, so that they link in together. This is a fund that teams of postdoctoral and doctoral researchers bid for, where they receive £2,500 as a team to deliver their own energy or net zero research events. We don't just give them the money though. What we're doing as well is to support them along the journey. So we work really closely with them to design, develop and deliver those high quality events. So it's the nitty gritty that we get involved with. We talk about audience, we talk about registration, we talk about things like EDI planning for those events and accessibility. So we get them thinking about every stage, and particularly things like the scheduling of a day and how much time to give different activities and so on. So they're really thinking about how to maximize those events for their purpose. On the right-hand side of the screen, we've run so far 3 events this year. So one in April, one in May, one in June. And you can see the range there. If you look at the titles, you can see the range of types of activities and the range of areas within the energy sector that we're working on. So I pick out the gender equality workshop What that did was, there was a certain number of talks and things, but it brought people together from across the entire energy research sector and involved them in a serious game at the end of the day, where they were looking at scenarios in various communities where energy transitions perhaps have undesirable effects. So looking at how they might improve those impacts and actually and lead towards more just and sustainable transitions. With the net zero debate, that involved a cross-disciplinary debate around digital brains and how to advance AI through research in energy fields. And the Birmingham Decarbonisation Summer School, a real strength of that was a 4-day event where GE Vernova were heavily involved as well as an industrial partner, where they got teams of engineers and PhD students from across the region together to talk through and design solutions, which they then had to come up with a business plan for and present that business plan. So really thinking about the commercialization, really thinking about the entrepreneurship alongside these developments. So through those kind of events, we really promoted across the region a real good engagement and that interdisciplinary engagement for mainly postdoctoral and doctoral researchers. The quotes on the left-hand side are quotes from some of the presenters themselves, talking about the learning that they got out of this. So developing practice and confidence in event planning and delivery, deepening understanding of translating research themes into meaningful practice-orientated academic exchange, and also talking about their advanced professional development in leadership and coordination. So it shows how valuable that experience was for all concerned. And then the second example on the next slide is our doctoral showcase. So just under a month ago, we had the ERA UK Energy Innovation Expo based in Derby. And within that, we showcased how doctoral research is driving innovation solutions for the energy sector across the Midlands. We invited 10 doctoral researchers from across our partnership who presented their research in 3 to 4 minute lightning talks. We supported those researchers at all stages, so we didn't just throw them into that. It was a big stage with flashing lights and dry ice and music and all sorts of things as they were coming on. It was quite an interesting experience. And they were presenting to an audience of about 400 delegates. So quite a big event in a big venue, quite different from some of the things they would have done previously. But we supported them through that again. So it's not just about giving opportunity, it's about supported opportunity. And we talked them through, gave feedback on presentations, both on the slides and the scripts that they were using. We talked to them about pitching to a diverse audience. We tried to engender that sort of cohort feel and give, so they engaged in peer support, which they did wonderfully. We gave them some opportunities to be involved in a podcast, and we also supported attendance through our travel and carer funds. And we're trying to sort of have a holistic view about how we can support those types of activities. So it gives you 2 examples of the types of events in our program that really try and encapsulate those sort of interdisciplinary, industry engaged and collaborative types of work. Now, I have a really great pleasure today to be able to ask 3 of our doctoral researchers who we have with us in the meeting today to present their lightning talks from the doctoral showcase, again exhibiting an opportunity for them to talk to all of you, but also exhibiting an opportunity to collaborate and to network and so on around their research. So the first of these talks, I'd like to welcome, please, Mandy Anyangwi from Keele University to give her talk on microgrid development. Over to you, Mandy.
Thank you. Good afternoon, everyone. As Keele rightly said, my name is Mandy from Keele University. So my research I have been exploring how we can integrate renewable energy into decentralized rural agricultural systems using case studies across the United Kingdom and Cameroon. Next slide, please. Right, so as you can see, the reason we are all here today is because we are all striving to see how we can facilitate the transition to net zero. So energy poverty and the transition to net zero, it remains a very major global challenge. And there's one thing, I don't know if you all already know, if you look at access to energy, not just transitioning to net zero, but just energy access. Across the globe right now, over 700 million people do not actually have access to energy. Talk less of thinking about how they can transition that energy. And at least 600 million of those people reside in sub-Saharan Africa, where I originate from. So if you look at the graph on here, it actually shows you the first graph on your right. Sub-Saharan Africa lies on here where you see the red line. Why the rest of the world, UK is right at the top with 100% access. But why did I decide to look at a comparative analysis? That is because right now, if we want to talk about the transition to net zero, we're all looking at different ways of doing it. I talked about how we can integrate renewable energy into agriculture, specifically agriculture, because when I think of sub-Saharan Africa, the least energy poverty is still a problem. Poverty itself is still a problem. So when you think about how people survive in that part of the world, the majority of people survive through subsistence farming. So if we start thinking about how we can integrate renewable energy in decentralized locations, then we can begin to not only provide energy access to a huge number of people, we can actually empower them from moving from subsistence farming into small-scale agricultural businesses. So that's a key reason why I did pick agriculture as a niche, because the whole problem is not just energy access, but what does this energy do? It's not just energy transition, but what does this transition do? How does it impact individuals? And then as you can see, the graph in the middle, it actually shows you how I actually got this result from the UK. It actually shows you how agriculture depends on energy. So across the UK and sub-Saharan Africa, we all need reliable and clean energy resources to increase agricultural productivity and also to facilitate the transition to net zero. And then when we look at now, how much renewable energy do we currently have? The graph on the far right, you can see here you have China. China is doing good compared to the rest of the world. And then you have the UK within Europe up here. And then right at the top end, when you don't even have any, there is something, but it's not very evident, that's where we have sub-Saharan Africa. So by comparing an advanced economy to a developing economy, it actually showed that, can I go to the next slide, please? Thank you. So that comparison, the findings that I found out, because what actually motivated me was that, yes, this problem is there. And as an engineer, my background is electrical engineering. As an engineer or as someone who has come from the industry and identified these problems before proposing a solution to it, I was telling myself that right now, if we look at all the technologies that are existing, we have more than enough technologies to implement solutions across the United Kingdom and Cameroon. But it's not happening. So I was very curious about what is it that is preventing implementation from scaling. So I decided to propose this framework. It's a very interdisciplinary research. I did look at a couple of things. I did a lot of data collections from literature review. So for my findings on literature review, I actually realized that integrating renewable energy into agriculture is not just a technical problem. There is a whole lot of socio-technical challenges attached to it. However, I did not just want to rely on what literature says. So I took myself into the field. I visited rural agriculture and energy services in the UK and in Cameroon. I spoke to stakeholders across the energy and agricultural value chain, beginning from policymakers, farmers themselves, NGOs, energy developers, researchers, universities, just to find out what their perception is, what do they think about integrating renewable energy into agriculture. And then there's also one thing which I observed. One of my key observations is that most of the farmers across the UK and Cameroon, they are not really worried. They are not really concerned about the technology because right now they have what they need. They just need energy. So not the majority of them will not really want to think about transitioning that energy, changing what they're currently using. So one way in which you can, which I realized I could get their attention, was actually to find out from them what is their pain point. What is it that is preventing them from actually scaling up their businesses or actually reducing their energy bills? Because when you start talking from them to identify their pain point, then you realize that you get their challenges that they are facing, and then you can now align it to our energy solutions, and you can now facilitate that transition. So the purpose of this conference, I will talk about the techno-economic assessment, which I did. So I did look at a variety of businesses, because I could identify that a lot of solutions already exist, but they don't scale, especially in sub-Saharan Africa. Most of the renewable energy that has been integrated, it just stops at where funding ends. So how do we actually make these solutions sustainable? So those were the key things which I was looking at. So I did realize that if you do a hybrid solution, integrating not just one source of renewable energy, solar with battery, a smart energy management system, and then also with the specific agricultural activities across the different seasons, and then you align it together, that is when you get a real value for money. And if you look at on the right, the diagram on the right is just the microgrid solution that has been proposed from my research. And then if you look at, there's a graph here that shows integration into renewable energy. I'm actually doing this research at Keele University for a specific reason. Currently, Keele has already integrated solar and wind on campus. So by looking at the integrating renewable energy into the campus, I could already start seeing how renewable energy performs across different environmental conditions, using the Keele-Sen data as my baseline unit. And then from my findings, you can see that when you integrate renewable energy into agriculture with a hybrid solution, the initial cost actually reduces. And also the graph, the blue area which you see, it actually shows that when you integrate renewable energy, more renewable energy in agriculture means that a huge reduction into carbon emissions. And that's one good way in which we can facilitate the transition to net zero. However, this solution is the same solution across both landscape, but the key difference is that you cannot use one solution for sub-Saharan Africa or for the UK, because they have different policies, different governance, different community challenges. You need to look into all these key challenges, and then you bring them together before you implement this solution. So the comparative findings highlight the importance of context, specific governance, and finance framework. Next slide, please. And yes, thank you. That's the end of my presentation.
Thank you very much, Mandy. That's great, and really good to hear from that sector in agriculture. So we're moving along now to Monica Amediavor from Cranfield University to talk about her research for the next 3 or 4 minutes. Monica, over to you.
Thank you so much, Neil. Thank you everyone for being on the line. So my name is Monica Amediavo, and my research is basically can net zero be sustainable without worker security? Rethinking career success. We want to reconceptualize what career success means in the gig economy. Please, next slide. Okay, so when we open the ride-hailing app, when we talk about the ride-hailing app, we mean Uber app and Lyft and all the other apps. But then in my context, I'm doing this research in the context of Ghana. So when we open the ride-hailing apps, which are the Uber apps, Yango apps, and then the Bolt apps, these are platforms that we have convenience on. It's like you being in the comfort of your home and then just requesting for a ride. And then you just get to go to wherever you want to go to. And this is part of the sustainable mobility agenda. And beyond all these convenience, what do we see? We see individuals who are ride-hailing drivers who maneuver all these platforms in order to be able to make a living out of it. And what is the problem that I'm looking at? When we talk about these apps, we have individuals who work behind platforms mediated work, and then these platforms have control over the individual's career. So we want to reconceptualize what career success means to this ride-hailing ride-hailing drivers beyond the sustainable mobility agenda of research. And then in the problem, we can see that these individuals do face income instability. And then the income instability we are talking about is drivers obviously do have maintenance costs. They do have rating that affects them to be able to get more rights. And they do also have family responsibilities and other uncertainties of whether their earnings will be enough. Yes, all these things are very important to ride-hailing drivers, but then not just that. They also have algorithmic control or management. These algorithm controls or management are part of like the people, individuals working behind the platforms, and these also affect the drivers. And in the context of Ghana, Ghana is muchly dominant with the informal work contest, which is one of the unique contribution to this study. But then what is the overall overall aim of this study? So to understand how ride-hailing drivers, who are the Uber drivers or the other platforms, how they define and how they pursue what career success means to them. You know, unlike somebody working in a formal structured organization, what career success means to them is about promotion, it's also about their career progression, right? But then have you thought of a ride-hailing driver who do not have anything called promotion in their work? They do not also have anything called career progression. But then, yes, they enjoy flexibility. They have autonomy over their work. These are things that ride-hailing drivers enjoy. But my research approach that is used to test or to collect data is I use the qualitative interviews to understand how these ride-hailing drivers understand career success. What are the challenges they face with pursuing their careers as drivers? Then also comparing it with the literature or papers within the career, what career success means in the gig economy. This brought a novel contribution to what career success means. We can also talk about the key findings from this study. The key findings from this study also reveal that drivers understand what career success means by seeing economic viability. They understand that when they are able to take care of their families, they are successful with their career. Of course, not every driver owns a car, but sometimes with their earnings, they used to get, enough to be able to take care of their families. They don't owe people and all that. These are the various contributions that my study brought. Then also we could talk about the work community as well. They see dignity to be very important because not most people see what career success means to be dignity. Others think that career success is just about being promoted with your work, but then they see the aspect of people not seeing their work to be respectable, and that for that reason they feel that for them success to them is about dignity. So please, next slide. Okay, so why is this study very important? This study is important because looking at the net zero agenda, we mostly focus on sustainable mobility. We also focus on how sustainable mobility is very important with the future of work. But we've forgotten individuals who needs to make a living, and also individuals who want to see their future or their work as decent and secured work. Because people working in the formal organization would enjoy retirement plans, would enjoy other form of securities, but ride-hailing drivers, because they are being seen as independent individuals working or self-employed individuals working on a platform, they do not categorize what success means to them in that way. And so it is very important that we have a just and inclusive net zero future when we incorporate individuals working behind the platforms as people who also future of work is very important. Then we can talk about how we can achieve this. It would implement for better policy, because policy, as we know, would go a long way to be able to be informed, and as policy is being implemented, this ride-hailing drivers would be able to when the policy is being implemented, they are able to enjoy what secure future or work security means to them. Yeah, and also we can talk about the driver's well-being as well. Yeah, thank you so much.
Thank you, Monica. That's really brilliant. So we come to our final presenter from the doctoral showcase, Steffi Shaji from Loughborough University. Over to you, Steffi.
Thank you, Neil. Hi, everyone. Good afternoon. As Neil has already mentioned, my name is Steffi, and I'm from Loughborough University, and I'm excited to present my research on hydrogen and CCUS metrology to you today. Next slide, please. So, imagine trying to bake a multi-million-pound cake, but your kitchen scales are fundamentally broken. You might have the best recipe in the world, but the final result is going to be a very expensive disaster. Currently, the global push towards net zero is facing this exact problem, but less cake, more measurement. We are building commercial scale hydrogen fuel hubs and also preparing to pump millions of tons of captured carbon dioxide into deep underground storage. So the engineering infrastructure is already ready to operate, but we are facing a critical invisible bottleneck right now, which is that our measurement science has not kept up to pace with this rapid engineering deployment. So, in the hydrogen economy, a trace impurity of just 4 parts per billion can irreversibly destroy a fuel cell. And in carbon capture networks, where carbon dioxide is transported at extreme pressures, miscalculating these trace impurities can have many knock-on effects, such as drastically altering gas compressibility, inflating operational costs, and it can also lead to the formation of acids that can internally corrode these steel pipelines. So I'm hoping that you start to understand that the metrology gap is quite stark. Our current routine industrial laboratories are struggling to achieve the extremely low detection limits that are required to prevent their infrastructure from failing. But on the other hand, academic literature tends to showcase novel spectroscopic techniques. However, the thing is, these aren't applicable. They are oftentimes either too expensive, too slow, or too delicate for the rough and ready industrial usage that they're needed for. So my research aims to bridge this gap between the capabilities in academia and what is commercially viable. So I'm currently developing an industrially scalable methodology using gas chromatography, which is the current industry standard for analytical equipment in high throughput gas analysis. So right now I'm preparing primary reference gas mixtures gravimetrically to establish a rigorous analytical benchmark to verify the exact linearities and limits of detection of inert gases within the carbon capture specification. And then with this foundation secured with the inert species, I then aim to do the exact same thing and use the exact same findings, but apply these to the highly reactive and corrosive species within the CCUS specifications. By proving the long-term stability of these impurities, I want to enable accurate calibration of the routine industrial instruments to ensure that they are compliant with accredited standards. So an analytical method that is metrologically perfect but commercially unscalable is just unviable. By building a unbroken chain of traceability back to the international standards and going back to my cake analogy, my work aims to give industry the precise scales that it needs to ensure our transition towards global decarbonization is practical, is safe, and is financially viable. Thank you.
Thank you very much, Steffi, and to Monica and to Mandy as well. And thank you all for presenting your research. It really illustrates just the range of research in the region around sustainability, around net zero, and around energy research, including social aspects and the engineering aspects. We have a little bit of time for questions now, and I know there's been quite a lot going up in the chat. I wonder if Nick, do you want to sort of take charge of that bit?
Yeah,
Or
sure.
Alan,
Yeah, sure. Thank you. Thank you again, everybody, for presenting today. Philip Sharman. Good to see Philip. He used to be on our used to be the chair of our industrial advisory board. So good to hear from you. Question to Sarah. I noticed RE was involved in developing PACER, Research England, that is. Do they use it in assessing applications for funding? Might this be an interesting tool for the UKRI funding family to use in assessing proposals and tracking avoided carbon emissions as the supported technology development progresses through the TRLs? Sarah, did you want to take that one?
So it's not currently being used by any of the funders, but I think as part of, Research England funded CDICE project, which was the organisation that developed the framework and also the toolkit. But it is something that perhaps we could, because since it's now been published through the journal, it's something that we could potentially contact funders about to see if they might be interested in potentially using the toolkit or signposting to, as part of that application process, this resource that researchers or people putting in applications might be able to utilise to make their applications more realistic or develop proposals based on whatever innovation that they're looking to fund.
Philip, any comments on that? If you want to unmute yourself.
Yeah, I think they would be interested. I mean, I joined the call because I was wondering whether PACER might be a useful tool for something called Zero Carbon Oxfordshire Partnership, where we've got about 30 organisations trying to shift the dial on greenhouse gas emissions in Oxfordshire, and some sort of tool that would help us understand the various research projects that are going on in Oxfordshire and how those might contribute, I think would be really useful. But so that was my reason for joining the call. But then extending that on, I wonder whether UKRI and RE and others might also benefit in using a tool that ultimately they've paid you to develop or helped pay for its development, and it could be a useful tool for them too. So yeah, if I was you, I would once you've got a bit of track record on it, I would present that as a useful opportunity for them. Thanks.
Thanks, Philip. And good to hear from you. Does anybody have any questions for our doctoral researchers and the subjects they were talking about? Do any of you, can I throw this out to the doc? Do any of you need to sort of make links with businesses? In terms of your research, are you looking for industrial partners at the moment? There might be people on the call potentially who might be of interest. Mandy?
Yes, I am. I am looking at farmers.
Right.
Okay. I need pilot projects, especially farmers that have already integrated some form of renewable energy into their agricultural processes. So I've got further work on my research moving forward on the next stage, which I will need that kind of collaboration.
And Mandy, this can be farmers in the UK or anywhere?
Yes,
Okay.
yes, because I'm doing a case study analysis. So the same work I'm doing in the UK, which represents the developed economies, the Western economies, is apparently the same work I'm doing in sub-Saharan Africa, which represents a scalable economy. So the framework it's the same, it's scalable, but it's context specific when you want to implement.
Right. Okay. So if you've got any farmers on the call or anybody who knows anybody in the farming community, let us know and we'll put you in touch with Mandy and potentially you can work together. But Steffi,
agricultural processes, anything
sure.
that has got to be, yeah.
Right.
Thank you.
And Steffi, the work you're doing, are you looking for partners, industrial partners to?
I am. So I'm currently working with I'm looking at purity analysis. So if there are people who are also interested or have done work on hydrogen purity analysis or carbon dioxide impurity analysis, I'd be happy to connect on LinkedIn or talk about it further. I've got a GCTCD and GCFID set up, but I was looking for industrial collaboration. If anyone's got any other high throughput gas analysis instruments, I'm open to industrial collaboration as well. Thank you.
Fantastic. Right. And finally, the same question for Monica. Monica, I don't know if your project also requires finding partners, industry partners.
Yes. Please, can you see me?
We can hear you.
Okay. All right. Yes. So I'm also looking for industrial partners and collaborations as well, because one interesting thing about my research is that it is a very unique context, and this hasn't been studied in the Ghanaian context, especially the collaboration between the career success and then the gig economy. So obviously, we all understand that this is a digital platform and that there is, more innovations coming towards the Western context as well. And with collaboration, that would be very helpful for this research to be, visible.
Great, thank you very much. So again, call out there for anybody who's interested in working with Monica. And Philip, I see that you've asked another question. This is to Steffi. Steffi, your approach to metrology looks like it might be really useful in the development of effective and quality assured SAFs. What do you think?
I agree. I think that my research hopefully will have a lot of industrial applications. So I'm doing it in both the hydrogen economy and also the CCUS sector as well. So I am looking to be able to we're looking to be able to develop reference materials which will be able to encompass many industries, whether that be SAF or fuel cell production. So yes, just being able to quantify what and how much of certain impurities are in your carbon dioxide stream or hydrogen. I do think that yes, it does have many applications.
Right, thank you. And then just finally, and Will, I think this is a good idea, is there an online platform to speed date researchers with industrial partners, as we're starting to see, for matching volunteers to volunteering opportunities? I think that's something we ought to take away and look at. A very good suggestion, Will. And yeah, Sarah's just commented in the chat. So thank you very much, everybody. We've reached 4 o'clock, and today we've just given you a flavour of some of the work that we do at ERA and some of the work that our researchers do. We've really just scratched the surface, but if you are interested in working with us or finding out more, or maybe coming to visit one of our facilities, then please let us know. Our website is era.ac.uk. You can find all the contact details there, and we'll certainly share all of these slides with everybody as well after the event. So thank you very much, everyone, and enjoy the rest of the day. Stay cool. Thank you. Bye.
Thank you.
Thanks very much.